Okay, so how do we solve this problem? So let's have a clear diagram of the problem first. So it says, here's a river and two swimmers leave point A on the bank of the river. So let's say this is point A and directly opposite there is point B. Okay, so one of them crosses the river along the straight line AB. So the first swimmer crosses the river along this line. Okay, the second swimmer swims at right angles to the stream. So he is swimming at right angles to the stream. So because there is stream velocity, let's assume that the stream velocity is V0. Okay. So since he is swimming at right angles to the stream, and the stream will take him this way. So his path of motion will be roughly along this line. Okay. And let's assume he reaches the point C, and then what he does is he walks from point C to point B. Okay. Now the problem also states the swimmer's velocities is both equal to V dashed. V0 value is 2 kilometers per hour and the swimmer's velocity is V dashed is 2.5 kilometers per hour. So these are all our given data. Okay. Now let's consider swimmer 1 first, the first swimmer. Okay. So swimmer 1. Okay, now if we assume that this distance is d, which is the width of the river, and let's also assume that this distance that the second swimmer walks is x. Okay, now for the first swimmer, if we draw his velocity vectors, so since he's crossing the river perpendicular, so basically his velocity v dash with respect to the stream will be at an angle, right? And then we have the stream velocity, which is v0, is this way. So the resultant of his crossing is in this direction. Okay? Now, if we assume this angle to be theta, okay, so for swimmer 1, can we say if he took t1 time for this travel, so let's assume t1 is time taken to cross the river. Okay. So v dashed cos theta is the speed along the perpendicular, right? So v dashed cos theta will be equals to d by t1. Okay. Now the other thing is v dashed sine theta, which is his speed along this axis, should be equals to v0. Why? Because the swimmer is not moving in either the right or the left. He is directly crossing the river. So these two components must cancel out. So then from this, sine theta is v0 by v dashed. Now how much is v0? 2, and v dashed is 2.5. So I can also write this as 5 by 2, so 4 by 5. Now this is a well-known triangle. If sine theta is 4 by 5, then cos theta is how much? Is 3 by 5. So we can say T1 equals d by v dash cos theta, or we can also say v dash is 2.5 and cos theta is 3 by 5. So this can be written as 5 by 2 or so 2d by 3. Now let's look at swimmer 2. Okay, let's assume, let's first draw his velocity vectors. Since the swimmer is swimming directly across, this is his v dash, and the stream velocity is this side v0. Now if I assume t1 as time taken by swimmer 2 to get to point C, t1 is time taken to get to point C. Okay, now getting to point C involves motion in two dimensions. One is the drift this way and the other is the crossing, right? And both of those took, this should be T2. So both of those took T2 time, right? So what does that mean? So to get to this, to cover this distance, which is the drift, so if I say this as C dashed, this is the drift, which is x, right? Again, the important concept here to understand is whenever there is motion in two dimensions, y and x, the component motions, there is a drift and there is the crossing, right? Both together makes him go here. So we can say that, and what is the velocity of swimmer 2 in this direction? It is v0. There is no component of v dash in this direction, right? So v0 is responsible for this drift, so which is x divided by t2. Okay. Now v dashed has no, so v0 has no component in v dash direction. So also it follows that v1 or v dashed is responsible for this crossing, so which is d by t2. Okay. So from this we can find out t2 is d by v dash. Now how much is v dash? 2.5. 2.5, which can be written as 5 by 2, so 2d by 5. Okay, now let's substitute this t2 here. So v0 becomes x divided by t2, which is 2d by 5, or we can say x becomes 2d by 5 into v0. What is v0? Is 2, right? So this is 4d by 5. So we got this distance x in terms of d. Now the second part is he walks this this distance C to B with velocity u, and let's assume that took him t3 time. Okay, so then u is x divided by t3, or we can say t3 is x divided by u, and what is x? 4d by 5 u. And the last piece of the puzzle is both these swimmers reach B at the same time. So which means T1 is what the first swimmer took time to cross from A to B, is equals T2, which is what swimmer 2 took from A to C, and then C to B is T3. Now we have T1, which is 2D by 3. T2 is 2D by 5. And T3 we just found out is 4D by 5U. Okay, now let's solve for U. Okay, so the time he takes to walk from C to B is 3 kilometers per hour. So that's the solution.